All right, y'all, this is MR, Mathematical Reasoning 4B. All right, so I'm going to show you my screen. I wrote down 4 formulas that we're going to go through for interest rates and fun stuff like that. So the first one here is simple interest. And it's a formula I would use when they tell me I got a simple interest or I got just interest rates that happen once a year. So to find that kind of interest, A would be the final amount that you get after ever how many years you invest. The P, that's your principal or your starting amount. APR right here is the annual interest rate, and we always got to use that in decimal form when we put it into the formula. And Y would be the number of years. So I'd plug all that in, and in this formula, you multiply first, then you add the 1. Then you take that whole amount and multiply by whatever your P is. Doing all that gives you your A. Now here's a compound interest. That's when they charge interest or give interest more than one time a year. They could do it semi-annually, which is twice. They could do it quarterly, which would be 4 times. Okay. Now see, if this n is just a 1, then that just becomes the APR, right? APR divided by 1 would be the APR, okay? Alrighty. Next, you got n here, that's the number of compounds. And then y is the number of years still, okay? So I would use that when they tell me I got compound interest. APY. APY is the annual percentage yield, and it's the percent of balance increases in 1 year. So to find that, APY, which is short for that, you take the absolute change. So the absolute change, I wrote it right here, that's the difference of the amount after 1 year. So I would use this formula and do it for 1 year. And you could start with any amount for the principal because you're just seeing what the bank's yield is versus your actual yield or your actual APY, okay? And then that'd be the difference. You find that value, you subtract your principal that you started with, and that gives you how much that changed for the year. So if you started with 1,000, and at the end of the year you had 1,080, you would take the 1,080 minus the 1,000 you started with, and your absolute change would be the $80. So you would put that on top, and then to find that APY, you divide that $80 by the starting principal you chose, which I said was 1,000. So I would do 80 divided by 1,000. That would give me a decimal. But remember, if I'm looking for this in percent notation, I would have to move my decimal right twice and add my percent. Okay. All right, this last formula finds the principal if you know what you want your amount to be. So say I wanted to save for a car, and I wanted to save for 5 years, okay? So I was going to go get me this account, and the account paid 5% APR, and it compounded, say, quarterly. So I would put the amount I wanted to save, which was probably what, 15, 20,000 here, the interest rate, the number of compounds, and then the years. So to work this formula, you're basically taking the A and dividing by everything you get here. See how I got the P times everything here? Well, if you wanted to get the P by itself, you would divide both sides by this whole thing, which is what they did under that A, okay? So we're going to work some examples starting with number 3 on the homework that go through using these formulas, okay? So I'm going to start with my number 3. The first 2 questions were sort of like multiple choice statement stuff. So you got to read the statement and pick the best answer. So I'm going to start with these questions. So this one says you invest $3,000 in an account that pays simple interest of 6% for 30 years. All right, so they said simple interest, so I'm going to use the formula I had for simple interest, which is my A equals P times parenthesis 1 plus my APR times the years. All right, 3,000 is your P. 6% is your interest rate, but remember, we got to move that decimal left twice and turn that percent into a decimal. So that's going to be 0.06 for my APR. So remember, that's going to be 0.06 now. And then we got 30 years, which is the Y. So let's put that in. 3,000 for the P multiplies by whatever I get inside these parentheses, which is 1 plus that 0.06 times the years, which is 30. So y'all, if you was doing this by hand, you would have to do the multiplying first inside the parentheses, then add the 1. Because you got to do inside parentheses before you can move outside of them. So you would get that whole answer and then multiply that by the 3,000 to get your final answer. I'm going to do this on the calculator. So I got 3,000 times parentheses 1 plus 0.06 times 30. Close my parentheses. So let me hit enter and I get let me see. I put something in wrong. Let me see. Oh, I put 31 years, y'all. Okay, let's clear that. 3,000 times 1 plus 0.06 times 30. Okay, I get $8,400. So after 30 years, just invest in 3,000 at a 6%. So they're just going to pay your interest once a year at that 6%. Okay, so it takes it a while to add up on those kind of cases. You want them to compound it, okay? If you ever do this. All right, here's another one. They're going to invest $3,900 in an account with an annual interest rate, which is simple interest, of 4.9% for 10 years. So once again, I'm going to use my simple interest. A equals 3,900. And remember, you'll know to use this formula because the other formula, they're going to give you those compounds, which is that N, okay? All right, so multiply this by 1 plus APR. You got to move that decimal left twice. So add a 0. And that's a 0.049 times my Y. Remember, there's my Y, which is my years, which is 10. All right, so here we go. 3,900 times parenthesis 1 plus 0.049 times 10. That's going to give me 5,811. So almost $2,000 at a 4.9% you would make in 10 years on simple interest, okay? All right, now watch this. And number 5 says, use the compound interest formula. So they're telling me I'm using my compound interest formula. All right, so here's the question. 2,000, so $2,000 invested at an APR of 9% for 6 years. If interest is compounded annually, what is the amount of money after those 6 years? So I'll use my other formula, which is A equals P times my parentheses 1 plus. Now remember, anytime you got a letter next to parentheses, that means you're multiplying, okay? All right, then it's 1 plus my APR divided by N, all raised to the exponent in t. So what I'm going to do is work the inside the parentheses. Then I'll figure out what this exponent equals. And I'll take what's inside the parentheses and raise them to that exponent. Then your final step is to multiply by the p. So you do inside the parentheses by dividing first, adding to 1. Then you raise them to the exponent. Then you multiply all that times the p. So my p is my 2,000 because that's my starting amount. That's going to be multiplied times my parentheses, 1 plus APR is my 9%, but remember I got to move that decimal twice to the left. That's going to be 0.09 all over N. So if it's annually, N equals 1. And then that'll be 1 times T, which we said was 6 years. So let me show you how you're really doing this by hand. You got the 2,000 times 1 plus. So you would first have to figure out what 0.09 divided by 1. But anything divided by 1 is itself. So that becomes a 0.09. And then now you can actually multiply that 1 times 6 because that exponent has to be multiplied before you use it anyway. All right, now you got the 2,000 times. I can add 1 plus 0.09 and get 1.09 raised to the 6th power. So then what you would do is say 1.09 exponent would be a 6. So I use that arrow up key to get my exponent, put in my 6, and hit enter. So basically that's 2,000 times whatever I got in the parentheses. So that's a 1.677100. But what I'm going to do is just leave that answer there and multiply that by the 2,000 and get my final answer. Now, we got to round these to the nearest cent. So rounding to the nearest cent, I got 3354.20. Okay, so 6 years at 9% interest, your 2,000 turned into 3354. So that's not too bad. So that was what, number 5? So let's see number 6. So you see the difference in these formulas? All depends on those compounds. Now see, that didn't do much because they only did it annually, which was basically like the simple interest. So here's another one. They're compounding annually. So they got 10,000 invested at an APR of 3.6%. 18 years. And then we said this was compounded annually. So since that's annually, N is going to equal 1. That's going to be my Y. That's my APR, but I will turn that into a decimal. So I got to move left twice. So I add a 0, so that's going to be a 0.036. And then 10,000 is my P. So A equals P, which is 10,000, times my parentheses, 1 plus my APR, 0.036, divided by my N, which was 1. And then my exponent is N1 times years. And my years was 18. All right, so I'm going to do this all on the calculator. So watch this. I got 10,000 times parentheses. So the parentheses are right above the 8 and the 9. So then you got 1 plus 0.036 divided by the 1. Close those parentheses, and then you hit the arrow up. Now, if you got the old calculator and it puts this on the screen like that, you got to do the 1 times the 18 and then close your parentheses on the older calculators. On the new ones, I just go 1 times 18 and it keeps it all up there. But y'all, if it does the arrow up on your screen with the little parenthesis, you got to put 1 times 18 and then shut your parentheses. All right, so which one am I doing? I'm going to hit enter and round this to the nearest cent. So I get 18,900. The nearest cent, I'm looking at the zero. Since that's a zero behind it, I keep it the same. So I get 18,960 cents. So see, that's not bad after 18 years. You've made almost $9,000 off of 10. All right, same thing, compound interest. We got 12,000 for 8 years. APR is 4%. Quarterly compounding. So remember, quarterly means 4 times a year. 4%, we would move the decimal left twice. So that would give me a 0.04. There's my Y, which is 8 years. And there's my P. All right, so let's plug that in. A equals 12,000 times parentheses 1 plus my APR, which is 0.04, divided by my N, which is 4. And then this exponent, N is 4 times my Y, which is 8. All right, y'all, so watch this. We're going to punch 12,000 times parentheses 1 plus 0.04 divided by 4, close parentheses, arrow up to get the exponent, and then that is 4 times 8. Once again, if you got the older calculators, you got to do 4 times 8, and then close in parentheses. All right, on mine, I hit enter. I get 16,499. All right, I got to round to the nearest cent again. So since that's a 28 with the 8 after my 8, I'm going to turn my 28 into a 29. All right, let's see. Oh, wow, y'all, check this out. 21,000 invested for 4 years. APR of 2%. Daily compounding. Daily means N is going to be 365. That is every day they're compounding it. 2%, move that decimal left twice, make that a 0.02. There's my Y, and there's my P. So once again, I got everything, so let's plug these into our formula. 21,000 times 1 plus 0.02 divided by N, which is 365. Well, all raised to the N, which is 365 times Y, which is 4. All right, y'all, you would think this is going to really blow up, but watch this. 21,000, because that's a low interest rate, times parenthesis 1 plus 0.02 divided by 365, close parentheses, and then hit your exponent. Exponent is 365 times 4. All right, y'all, let's hit enter. And notice I only got $22,748. Rounding that to the nearest cent, that 7 is in my cents, so I need to round that 7 up because that's an 8, so that's going to be a 98. Alrighty, so 4 years you made about 1,800 almost. Alrighty, here goes number 9. Same thing, 7,000. So you're going to do this formula enough to learn it, I guess, right? 11 years, APR of 2%, monthly compounding. So monthly means N is 12. 2% once again becomes 0.02. 11 years is my Y, and there's my P. So I go plug everything in. 7,000 times 1 plus 0.02, my APR, divided by N, which is 12, all raised to the N, which is 12, times years, which is 11. All right, here I go. 7,000 times parenthesis 1 plus 0.02 divided by 12, close parentheses, and then the exponent is 12 times 11. And looks like I got everything. So $8,720. And let's see, 93, that's a 9 behind that 3, so that's going to become a 94. And we are done. Okay, that's number 10. No, we just got 15 of these, so I'm on 10. Same thing, 25,000. 6.2% is my APR. Quarterly compounding for 33 years. Okay, so quarterly means N is now 4 again. We got to move this decimal left twice, so we get a 0.062. And then once again, there's my P. And then that was my Y, right? So now I can plug everything in. 25,000 goes here, times my 1 plus my 0.062 divided by my N, which is 4. And then this is 4 times my years, which was 33. So I would expect this one to make me a little money, because 33 years is a while, right? So let's see, 25,000 times parenthesis 1 plus 0.062 divided by 4, close parentheses, exponent is 4 times 33. All right, looks like we got it in. So, oh, what I get? 190. So that's $190,410. And let's see, 31. That one's got a 4 behind it, so I'm going to leave that a 31. And we are done. So, 33 years, $25,000 compounded quarterly at 6.2%. You've almost got a $200,000. That's not too bad. You invest that when you're 19. Well, look at that. By the time you're 52, 53, you got almost $250,000, okay? And that's really what we want y'all to see on these. Now we're going to find the annual percentage yield in the following situation. A bank offers an APR, so the bank APR is going to equal 4.2% compounded daily. So on this one, you're just wanting to see if our APY is actually better than this 4.2, because when you compound it a lot, you actually get more money than you would think, because it gets you a little bit extra due to all the compounding. So first thing, remember, I got to find out what this gets me in a year. So I just pick any random starting amount, and I always use 1,000 because that's easy to multiply and do stuff with. So we would use this formula still to A equals my P, which is my 1,000. I just made that up, remember. 1 plus, well, 4.2, we move that decimal left twice, That's 0.042. Daily is what? 365. And then this would be 365 times 1, because we're just looking at what's this going to do in 1 year. All right, so same thing, work this formula out. So here's my 1,000 times parenthesis 1 plus 0.042 divided by 365, close parentheses, exponent 365 times 1. Because you're just doing this for the year to compare the rates. So I get, that gives us $1,042, and I'm going to call that 89 cents. So to find, remember my APY formula was my absolute change over my principal. Well, my principal was that $1,000 I started with. My absolute change is going to be this 1,042.89 minus my starting amount, which was the $1,000. So you see what you made for the year, subtract that 1,000. So you subtract 1,000 from that. I'm going to get what? $42. So the change up here is $42.89. So that's what this gave me. Then divide that by the principal I started with, which was 1,000. Now, if you want to put a 10 here, you can use a 10. You can put 100 here. You can put 200 here. You can use any amount you want to, because we're just using the theoretical amount to see what this interest rate is actually having done, okay? So watch this. 42.89, divide that by 1,000. And the actual percentage yield is 0.04289. But remember, I got to move this twice. 1, 2. So that actually gives me a 4 point. Now let me see how they rounded this. 2 units. So 2 units would be, there's my, after my decimal, so I need to go these 2 units. So since that 8 has a 9 after it, I'm going to turn the 8 into a 9. So my actual annual percentage yield is 4.29. The bank had 4.2% that I was going by. So notice, I'm almost 900ths higher overall than I was. So you made 9/100ths more money through the year, okay? You didn't make just 4.2%, you made 4.29%, and that is really, really close to 4.3. So you almost made a 10th higher, okay? And that is all because of them compoundings. All right, so that was 11, right? So here comes 12. Same thing, I'm doing the APR again. This time the bank has an APR equal to 3.97% compounded monthly. So once again, I'm going to let my P equal 1,000. On this one, I always use 1,000 when I'm looking for that AP annual percentage yield. Okay, so first we got to find what we actually made. Monthly means N is 12. So here we go. A equals 1,000 times 1 plus. All right, move that decimal twice left. So that's a 0.0397 divided by N, which is 12. And then up here is 12, which is N times 1. So we're not changing that exponent really, because that's a 1. All right, let's push that in. 1,000 times parenthesis 1 plus 0.0397 divided by 12, close parentheses, exponent 12 times 1, which is 12. So I'm going to hit enter. So I got $1,040.43. Now remember, I'm finding since I'm doing the annual percentage yield, I'm looking for my absolute change on top. So I take this amount minus the 1,000 I started with, and that's going to give me $40.43. Now, divide that by your P, which you started with, which was the 1,000. This is going to tell me what percent I actually made through the year. So 40.43 divided by that 1,000. So we made 0.04043. Remember, I got to turn that into a percent by moving my decimal right twice. Now remember, I'm doing these to 2 decimal units, so that's going to be 4.0. Since the 4 has a 3 behind it, we're going to keep that a 4 and put our percent. So notice, once again, 4.0%. I actually made more off my money than I thought at 3.97% because it compounded 12 times. Now remember, if this was annually, the APR would equal the annual percentage yield because it's not getting compounded but that one time anyway, okay? All right, y'all, this is using my last formula that I gave you for these ones. How much must be deposited today into the following account in order to have $40,000? So you want $40,000. So that's what we want. We want that in 5 years for a down payment on a house. Now, we have an account with an annual compounding, so it's annual on the compounding, which is once a year, and the APR is 5%. So remember, that's going to be what, a 0.05. N will be 1. There's my Y. This time, remember, this is my ending amount that I want. I'm looking for the principal that I got to put down to get that amount. So remember, that formula I gave y'all was P equals A divided by 1 plus my APR divided by N, all raised to the exponent N times Y. So you get your A and you divide by everything down here to get your final principal that you need, okay? So we got everything we need. We got A, which is 40,000. So that's what I'm wanting to end up with in 5 years. So I'm going to divide that by 1 plus my APR, which was what, 0.05, divided by N, which was 1. And then the exponent is a 1 times the years, which was 5. All right, so watch how I do this on the calculator. I'm going to do 40,000 divided by parentheses 1 plus 0.05 divided by 1, close parentheses, and then the exponent is 1 times 5, which is 5. So I hit enter. So this is telling me that I need to start with $31,341, and that's going to be what? 0.04 with a 6 becomes a 0.05. And then, so y'all, if I want 40,000 in 5 years, and I'm only investing it at 5% with a annual compounding, I've got to put in at least $31,000. So I'm going to make about 9,000 in them 5 years to help me buy that house, okay? All right, 14. Same type of question. You want to have $50,000, so you want $50,000 in 6 years. And y'all, you can use these formulas if you can put your money into an account and you know what you want to have. Use this formula to figure out what you need to invest. So this one, they want a down payment on the house also. So they're getting an account with monthly compounding. And APR is 4%. So remember that 4%, I'll move that left twice. That's going to be a 0.04. Monthly means N is 12. There's my Y, and there's my A. So remember, I'm looking for the principal that I need to start with to get these kind of amounts. So 50,000 divided by parenthesis 1 plus my percent, which was 0.04, divided by n, which is 12, all raised to the 12 times 6. So that was my 6 years. So here we go, 50,000 divided by parentheses. If you don't put parentheses, this problem will not work. 1 plus 0.04 divided by 12, close parentheses, exponent, 12 times 6. Now remember, once again, if your calculator's putting that on the screen, you got to do 12 times 6 and close parentheses for your exponent. All right, hit enter, and this is going to give me $39,347.09. So you still got to start with quite a bit to make 50,000 in 6 years if you got something getting compounded 12 times, okay? And that's a year. But say you sold a house and you had about 40,000. Well, hell, 6 years you could get a 50,000 down payment versus your $40,000 down payment roughly, okay? All right, y'all, same thing. Woo, this one wants to have 105,000 for a college fund, and they want that in 12 years. They're going to invest that in an account with an APR of 7.66%, quarterly compounding. All right, so this is our last one. So we're still looking for the principal you got to start with. So that's going to be my P equals my 105,000. So y'all, that's quite a bit, right? But college is expensive. So they must be wanting money for their kids to have to go to school, and they figured out they need about 105,000, okay? So let's divide that by 1 plus. This becomes a 0.0766 divided by n, which was quarterly, which was 4, all raised to the exponent 4 times y, which is 12. All right, so here we go, 105,000 divided by parentheses 1 plus 0.0766 divided by 4, close parentheses, exponent is 4 times 12. All right, so here we go. I get $42,243, and that 51, since that's a 7 behind the 1, that's going to become a 2. So if I want 105,000 and I'm getting about a 7.66% interest rate, and I got to do this in 12 years, I need to invest 42,000. But look what I made in those 12 years, y'all. That 105,000, if you subtract 42,243.52, that means I made $62,000 in those 12 years to help towards my kids' college. Okay, so that's the use of those 4 formulas I gave you. So remember, if you're watching this first, write these 4 formulas down real quick. This tells me what I start with. This simple interest, this compound interest tell me what I end up with, okay? So I'm looking for what I would start with using this formula. And then remember this annual percentage yield, I took the absolute change by finding what the bank would give me with some amount I picked, found that difference, and then I divided by the principal to get that decimal that I turned into a percent, okay? So if you have trouble in this with these percents, do your MR support for 4B, because that's all I did in that was convert decimals, fractions, and percent, okay? So we're going to stop this share, and y'all, I'll see y'all next week.